In this video, we're going to talk about one of the primary attributes of complex numbers that will help us in other applications involving complex numbers. And that attribute is called the modulus of the complex number. Now, the modulus is just a fancy word for absolute value of a complex number. And you may think, well, how can a complex number have an absolute value? Well, remember that the absolute value of any real number is just the distance from that number on the number line to zero. And the same thought applies when we calculate the absolute value or the modulus of a complex number. The modulus of a complex number is just the distance from the origin 0, 0 to that point in the complex plane. And the formula that we'll use to calculate the modulus is absolute value of z, which just means absolute value of z, or modulus. And that's equal to the square root of a squared plus b squared. And you may say, well, where did that come from? Well, here we have a point in the complex plane, a plus bi, or you may want to look at that as a comma b. However you choose to interpret it is fine. But here we have this point, a plus bi. And we want to figure out a formula for the modulus, or the absolute value of that point. Well, we notice that this point is a horizontal distance of a from the origin, and then a vertical distance of b. And we notice that this forms a right triangle. So I'm thinking that the Pythagorean theorem should apply here, and that the hypotenuse of our right triangle represents the modulus of our complex number a plus bi. Applying the Pythagorean theorem, we have a squared plus b squared should be equal to my modulus squared. So in this case, I'm going to let the length of the hypotenuse, because that represents the length of my, or that represents my modulus rather, I'm just going to let that be the modulus squared. So we would have a squared plus b squared equals modulus squared. Now let's solve this for m, for the modulus. If we take the square root of both sides, we would have the square root of a squared plus b squared is equal to the modulus, or the length of the line segment connecting the origin to our point a plus bi. So that's where our modulus formula comes from. It actually comes from the Pythagorean theorem. Now, because the modulus of a complex number is just the distance to that point from the origin, the modulus will always be a positive number. It can never be negative because it's a distance. So let's find the modulus of this complex number. Remember, modulus just means absolute value or distance from 0, 0. Well, I know that the formula for my modulus is absolute value of z is equal to square root of a squared plus b squared. In this particular example, we're given that z is equal to -1 plus square root 3 over 3i. That means our a, or our real number part, is -1, and our b, or the imaginary part, is square root 3 over 3. So we have square root of -1 squared plus square root of 3 over 3 squared. And that's equal to the square root of -1 squared is 1, and square root of 3 over 3 squared is 3/9, which is equal to the square root of 1 plus 1/3 if we reduce the 3/9, which is equal to 1 is 3/3, so we would have 3/3 plus 1/3 is 4/3. Square root of 4/3 is the same thing as square root of 4 over square root of 3. Square root of 4 is 2, so we would have 2 over the square root of 3. Now, if you choose to rationalize this, we could rationalize this fraction by multiplying the numerator and denominator by the square root of 3, and that would give us, in rationalized form, 2 times the square root of 3 over 3. So this point in the complex plane would have a distance of 2 square root of 3 divided by 3 units from the origin.